our last of the 3 videos that looks at business intelligence and data analytics processes and how the processes within business intelligence and data analytics are part project management, part business analysis, part information systems. And so the focus of this video here is on how data analytics is an information systems process. And as we look at these different processes, we'll keep in mind a couple of examples we've been looking at. One is an operations management example where we want to remove rancid meat from the grocery store shelves as soon as they turn, but not a second sooner, so that we can reduce waste and make sure we move our inventory. If we're doing psychology research, we want to quantify the impact of Instagram on mental health, or perhaps we are in finance and we're trying to predict stock values. So let's just go back here. In our previous video, we were looking at business analysis, which includes understanding the organization, enterprise analysis. What is the mission and vision of the organization? How does the organization measure how well they're performing, their KPI? What are the constraints for the organization? And how do you initiate change? We looked at how you would collaborate and elicit information from stakeholders. And we looked at how any project would need to align with the strategy of the organization, to add to the strengths, to reduce the weaknesses, to help with the opportunities, to mitigate the threats, and to add value. And we would need to do a risk assessment to ensure that there wasn't too much risk to the organization or the project itself. So we looked at requirement analysis, what needs to be done, how do we define quality in terms of a solution or a strategy for the organization. And so this means that the organization is looking for potential solutions. Now, in the example we've been working through already, we already had a solution. We were going to design a machine learning algorithm to identify rancid meat and to tell us when it needs to be removed. So we'd already gotten the solution. But if we're doing this for our organization, we would need to understand the organization first in order to initiate the project. And we would need to identify potential solutions. And so here when we're looking at potential solutions, this is where the information systems process comes in. And of course, all of this is tied together with our project management process, which looked at defining the quality of the project and looked at making sure that we were measuring the success of the project and who was involved. So you can see all of these really quite overlap. Well, the information systems process is the process of designing algorithms to handle data. So in terms of the information systems process, we need to understand the business. Again, that business analysis. What is the business trying to be? Who do they want to be? What are their values? What are their constraints? How does what we're trying to do tie to strategy, and so on. So if we understand the needs of the business, then we can do data understanding. So data understanding says, okay, well, if we're going to look at images of meat, we need to understand what kind of information we can get from pictures of steaks. So data understanding is exploratory data analysis. If we're doing a survey, we would do quick descriptive statistics of each survey question. What type of information can we collect in the survey? So helping to better understand what data we have and what the data tells us. We're going to spend more time on exploratory data analysis in upcoming videos. Then we have data preparation. So this is what we call data engineering, where we extract the data from its source and we transform it into a usable format and then load it into our system. So if we are using webcam images, then we need to extract it from the webcam into picture or video format. We then need to transform it into something that we can analyze. In a survey, for example, you might take questions that, let's say it's an open-ended question that's a number. How many years have you been with the company? People answer 24, people answer 5. We might want to convert it into bins, so 0 to 5, 6 to 10, 10 to 15 for our analysis. Okay, so what format does it need to be? as we look at analyzing text, we're going to have to transform the text into tokens. So there's different transformation depending on the data source. Okay. So we're extracting the data. If it's from a database, we need to pull the information from the database. That's why you did some MySQL and pulling with data from BigQuery in the Google Cloud. And then we transform it, we pull it over into what we need, and we load it into the system. So make sure that we have it in Python, if that's where we're doing our analysis, and make sure that we can load it into, if we're doing machine learning algorithms, we would need to separate the data into test and train. So we need a data set where we can train the algorithm, and then we need a data set where we can put in new images or new data and see how well it identifies or classifies the information. So that's all preparing the data for our algorithm. So then we have a modeling where we are actually going to tweak, tune the algorithm, improve its ability to identify rants and meat, improve our forecasting model. If we're trying to forecast stocks, we would need to look at what kind of data do we have. So understanding the data we have about the stocks, about the business environment, preparing it. So let's say we're building a neural network to do our analysis, and then we're building that neural network algorithm. We then need to evaluate the performance of our algorithm. So what we're going to be looking at in our coming videos is how do you assess the quality of your algorithm? So is it really able to detect what you say it should detect, or classify groups into the correct groups? So once we have this algorithm, we fine-tuned it, and we've increased its performance, then we create a pipeline. We want to deploy it. We want to make it so that it's continually updating as new information comes in. The algorithm has an opportunity to improve and tweak. And then how is it going to be accessible? So perhaps we have an API, an application programming interface, maybe it's web-based, in order to see the results, get updated information. An information system might be a recommendation algorithm. So it's recommending either that we remove a product from the shelf, or maybe it's recommending we watch a certain Netflix video. So in our information system, we need to understand what is it the model is trying to resolve, what kind of data we have and what the data tells us. How do we transform, extract, prepare the data so it can be utilized, build the model, assess the model, improve the model, and then deploy the model, automating some of these processes with pipelines, making it accessible with an API. So when we're looking at business intelligence and data analytics, we're a bit project management, right? We have all those components as we look at what's involved in terms of data collection, who's going to do it, and all those pieces. We have business analysis, where we understand the organization and its needs so that we know why we're initiating this project. And then as we look at potential solutions and how we're going to actually do the data analytics, we have our information systems process. One more process to add here is the data analytics process that has existed before machine learning. And so some of the analytics we're going to be doing in our videos is not complicated coding. It is more traditional data analytics methods. And so we'll look at one more process here, which is the more traditional data analytics process. So pre-AI, you would have a problem formulation, a solution design. You would develop that solution. You would test it or pilot it. You would deploy it. That's a continual process where you keep reevaluating and improving. You measure its success. You look at maintaining the solution, and then you sunset it. You should notice that this looks a bit like the information systems process in terms of we're looking at why do we need a solution? What could the solution be? And then how do we measure how well it's working? How do we tweak it? And how do we deploy it? So it's got similarities here to the more techie solutions that we'll be looking at. So just kind of outline a bit more. If we think about the forecasting of stocks, you're looking at a traditional forecasting model, not a complicated neural network, but just a simple, regression that we could do before AI, before machine learning. So we need to look at what needs to be predicted, what needs to be optimized. Our solution design considers what the relevant data is for our model. And here, if we are doing more traditional analysis, what distribution is relevant? So is it more of a continuous distribution? We have beta, we have Poisson. We'll look at a number of these in other videos. But what is the relevant data and what type of distribution does it have? Will depend on whether the data is more discrete or continuous, and we'll look at more of that. What's the probability that it's more concentrated, like a normal distribution, or is it that everything is equally likely, so it's more uniform? Then we need a solution development. So we need to come up with a model. So is this a linear regression model? Is this that we are going to go with a beta distribution that's going to help us optimize our solution? And so then we're going to pilot it, try it out. So if we're forecasting stocks, we forecast some stocks. And then we calculate measurement error. How far off are we from what really happened? And it's a continual process. We measure our success. We look at how well it worked. Maybe we tweak that regression model. And we do maintenance so we can improve and fine tune. And then at what point do we sunset this? So what conditions do we stop forecasting into the future? So when we look at this, as we add in lots of processes, one final process that it ties to is the continuous improvement model that's used in quality management. This is the Deming cycle, or the PDSA model, plan, do, study, act. And so as we look at these models, and you look at here our solution development, pilot, deployment, measuring the success, maintaining it, it is a continual process. So what we do is we define the problem, we analyze the issue, we determine possible causes or solutions, we test out the solution. So this implement solutions you see in the Deming cycle is that pilot. We evaluate it, so we're measuring how well it worked. We see if it worked well. If it did, then we implement it wide scale. If not, we tweak it, and it continues. We're constantly improving our models, our methods, as we're trying to improve the organization and the decisions and the recommendations that we're making. So whether we're doing more traditional data analytics that's not high-tech machine learning AI, we still need to understand, what does the organization need? What information do we need? What possible solutions can we have? How do we measure quality and success? How do we improve the model, and how do we sunset it? So business intelligence and data analytics, which is moving right towards more machine learning and artificial intelligence, is a bit of all of these. We need to know project management and those parts in order to set up the work for our collection, analysis, and recommendations. We need to know business analysis in terms of understanding the problem, the value added to the organization of it, and how it impacts the organization, and how the organization measures success. We also need to know the information systems process in terms of how do we go about preparing our data and creating an algorithm and assessing the algorithm. And then even if we're not using a complicated method, we still need to be able to continually improve the process and the solution and measure the success of it, even if it's not a complicated AI model. So what we're going to be doing as we go through our future videos and we actually do our data analytics, we are going to be applying all of these different processes in our collection, analysis, and recommendations.